In this video we're going to solve for the volume inside this tank. This tank is partially full at that level, h from the bottom of the tank. We have a radius r and we have a length of the tank L. If this tank was full of liquid, we would solve it by using volume equals pi r squared times length, pi r squared being the area of the end piece there of the tank, of the cylinder. But because it is not completely full, we need to tackle this problem differently. So if I draw the end of the tank here, we have the level of fluid inside it there. We have a radius center point of the tank there. If we were to draw lines out to the edge, it would be R. So we can see we've broken the section of the water that we need to calculate the area for into a triangle and a section here. So this triangle can be calculated, the area of this triangle can be calculated as half base times height, and this section here can be calculated as theta, that angle there, over 360 pi r squared. So let's neaten this diagram up. We have a triangle there. That's the water level there. We know that the distance from there to the base of the tank is h, and we know the radius is r. So we know this distance here from the center of the tank to the fluid level is h take r, but we don't know this distance from there to there. But let's use Pythagoras to calculate it because we know the other two sides. So Pythagoras says c squared equals a squared plus b squared. C is r in this case, so let's make this side a. So a equals c squared take b squared and take the square root of that. So that equals r squared take h take r squared. Okay, so the area of that triangle there equals half times the base, which is h take r, times the height, which is a, which is this one here, that's the area of one of these triangles, but there's two of them, so we'll times that by 2. We've calculated the complete triangle area, but we need to calculate all of this down here. So if we were to draw a straight line across here, we need this angle and we need this angle plus this angle here, which is the same as this angle here. So we have sine theta, call that theta, equals opposite over hypotenuse. So theta equals that. And remember, we're trying to get the formula here for the area of that sector. So we have theta there and theta there. We also have theta there, which is equivalent. And this one here is 180 degrees. So it'll be theta, which is 2 sine inverse sine h take r over r. 2 because we have one angle here and another angle there, we need to add them together, plus 180, that's our theta, that's all over 360, then multiply that by pi r squared. And this formula here is now the complete area of the fluid on the end section there of the tank. So we've now calculated this part. We now need to just multiply this whole formula here by L, and that will give us the total volume of this tank. So volume of the tank equals A times. We can also see we can simplify this formula a little bit more. We have a 2 here. This 2 cancels out with this 2 here. So we're simply left with h take r all multiplied by this square root here in brackets. Then plus this part here.